Human-powered vehicles have been in existence for thousands of years, and still today they are a vital form of transport, recreation and exercise all around the world. The most common form of human-powered vehicle is of course the bicycle. However, it is by no means the only one. Today, human-powered vehicles come in a vast array of different configurations and serve a wide variety of functions. Some designs are sophisticated, some interesting, and others, well, a little ridiculous. Despite the countless existing human-powered vehicles in the world today, designs are constantly evolving and new, innovative solutions continue to be made.
Our team has been tasked with designing a novel human-powered vehicle for a major design project. Our team has defined key project objectives, which are to develop a human-powered vehicle design that is safe, innovative, marketable and practical. In order to achieve these key objectives, we decided that the following constraints were necessary. The vehicle will be land-based, have rolling contacts, have a single rider, be less than 1.5 metres wide, and comply with Australian road rules and design standards. By the end of this project, we aim to have a functioning prototype as well as a CAD model of the final marketable product. The prototype will aim to demonstrate the functionality of the key design components. Following the success of this prototype, we aim to further develop the CAD model to produce a 3D printed scale model of the final marketable product, with which we aim to target the Australian recreational user market.
The design methodology we will be following to achieve these aims is shown by this flow diagram. This flow diagram illustrates each design process, as well as iteration cycles that will lead to design improvement and optimization. After defining the key project objectives and constraints, we then developed a morph chart. This morph chart lists all the necessary functions for the proposed vehicle, as well as various means in which to meet these functions. The morph chart provides a range of alternative design options, which was then used to generate conceptual designs.
To determine the most effective design, 3 potentially successful conceptual designs have been considered.
The first design utilises the powerful rowing motion to generate power. The sliding seat permits a full range of motion, offering a natural rowing motion. The vehicle has 1 front wheel, 2 rear wheels and a solid leveraging handlebar to both power and turn the vehicle. The second design also utilises the rowing motion to power the vehicle, however with minor adjustments. We have conceptualised a mechanism that allows the user to be seated in a fixed position while still generating power through the leg motion. This is achieved by having a sliding foot pedal system which couples with the leveraging handlebar to power the drivetrain. The last conceptual design uses power generated from a hand cycling motion. Again, the frame is stable with a 3-wheelbase arrangement. The steering system couples lean steering with handlebar pivoting mechanism. The conceptual designs were compared using an objectives metric table, which ranks the designs based on their ability to satisfy scaled objectives. Conceptual Design 2 was deemed the most suitable design and has the greatest potential for innovation. As a result, this design will form the basis of our future design considerations.
My name is Justin and I'm the project manager of the team. I'm responsible for the organisation and coordination of group members, resources and activities in order to ensure that we achieve the project objectives. To do this, extensive planning has been made. Firstly, a work breakdown structure was developed to divide the project into manageable sections. Team members have been allocated to each section, as well as an estimated portion of the total labour hours, giving us valuable guidance for project scheduling. Based on this work breakdown structure, a detailed Gantt chart was made to help us visualise the project schedule against key deadlines. This Gantt chart is an invaluable tool for the management of the project, and it will be regularly updated. I will be in charge of weekly controls to compare actual progress against plans. As illustrated by the work breakdown structure, each team member has a specific role for the project. This way, each group member has an opportunity to actively contribute to the final design and group efficiency is maximised. I will be focusing my design efforts on the frame of the vehicle.
Hi, I'm David. and my primary roles in this project are market analyst, build supervisor, and budget manager. My duty as market analyst is to understand our team's competitors and to monitor sales of existing products. This information will aid the team in determining our target budget and the marketability of the proposed vehicle. As the build manager, it is my job to oversee the prototype build process. To do this, I will work closely with the design team to transform the design drawings into a successful prototype. I will manage the materials acquisition and communications with potential suppliers and workshop members. It is also my duty to ensure that we remain within our target budget and build schedule.
Hi, my name is Ben, and my primary team role within the group is CAD and FEA Manager. I'll be working very closely with Lloyd, who is responsible for providing me with the design blueprints to work with. Lloyd and I will work collectively to iterate and optimize the final design to satisfy all design functions. The CAD model will be the basis by which the prototype is built, so myself and David will collaborate extensively to ensure the build is successful. My specific design role of the project is to handle the material selection aspects for all the vehicle components.
Hi, I'm Lloyd, and my primary roles for our project are Design and External Communications Manager. As a Design Manager, I'll be required to work closely with all members of the team in order to ensure all vehicle subcomponents interface precisely and function as necessary. I'll be overseeing each step of the design process, working closely together with Ben to achieve the end goal of completed design drawings. I'll also be working alongside David to ensure that build quality aligns closely with the design requirements. As Communications Manager, I'll be the middleman between our team and any external parties that may be interested in sponsorship of our project.
Hi, I'm Tom. My primary responsibilities for this project are feasibility analysis and ergonomic design. As part of the feasibility analysis, it's my role to ensure that the vehicle can be appropriately powered to navigate typical urban Australian terrain. To achieve this, I will investigate power output charts in conjunction with topographic maps. I will also look at the ergonomics aspect of the design, which will encompass monitoring the design of all component subsystems to ensure that it is user-friendly. The vehicle must be ergonomically designed to fit a range of user measurements. This will most likely involve adjustable component lengths and comfortable user vehicle interfaces. I will be working closely with the design team to ensure that ergonomics have been considered. Our team has been tasked with designing and building a novel human-powered vehicle. We have outlined that the key objectives of the project are to design a vehicle that is safe, innovative, marketable, and practical. A design prototype will be built to demonstrate and optimize the design functionality. Following this, computer modeling of the final design product will be developed and a scale model 3D printed. Based on the project objectives, 3 conceptual designs were developed. Using these, it was determined that a rowing-style drivetrain was the most suitable. Each team member has been assigned a specific role within the group. Management tools such as Gantt charts have been utilised to ensure that all necessary steps have been made to effectively allocate resources to achieve the project goals. Looking forward, we are currently working towards finalising our preliminary design and assessing the manufacturing feasibility of the chassis, steering and drivetrain mechanisms.